So that I wanted to know that how much you are aware, how much you are alert in finding out dihydrogen oxide. Okay. How much alert you are about the name dihydrogen oxide. So don't be afraid of it. It's water. Similarly, sodium chloride. Where will you find sodium? Yes. Where do you find sodium? Aryan, what are the sources of sodium? From where can you get sodium?
Sir, sodium is the metal, no sir.
No, sir. Sodium is the metal. So from where do we find sodium?
Sir, rocks.
Yes,
Sir, rock.
rock. Okay. Let me
Yes,
see
sir.
how much you are aware. Okay, Abhinav, from where can we find sodium?
So can it be a mineral too, like in waters or stuff?
Okay, can we find sodium from seawater?
So we can find sodium from sodium chloride only.
Okay, and is the sodium chloride in seawater?
No, sir. It will cause a very big reaction, sir.
Yes, seawater is very salty, so seawater has a lot of reserves for sodium chloride and sodium. You can obtain sodium from sodium chloride in the seawater. Okay. So be aware of the natural things also.
Sir, but doubt, sir.
Yes,
Sir, if sodium is present in water, no, sir, then it
yes.
will cause a very big reaction, no, sir.
No,
Like,
it is in the ionic form. If you put your salt in water, does it cause any reaction?
no, sir.
No. Why? It's present in the ionic form. When you dissolve sodium chloride in water, so your sodium chloride forms ions. It forms Na plus and Cl minus. It forms Na plus and Cl minus ions. Okay. So sodium, the results, why we are not finding sodium to be reactive? Your pure sodium water, sodium metal is reactive. And why it is reactive? Because the sodium metal can easily form Na plus ion and give you one electron. Okay. And this process is an exothermic process. Okay. So here in the solution, it is already in the form of Na plus ionic form. Okay, why do you all of you think that apple contains iron? Does apple contain iron or not?
Yes, sir.
Yes. So can we eat if iron is required by our body, can we take a piece of iron and eat it? Can we take some powders of iron and eat it?
No, sir.
So what is the difference between that apple iron and the one iron which I am talking of?
Isn't this the metallic form? Like,
Yes, it's very close, very close. Pranay, very close. One is in the metallic form, and the other one. What about the iron in the apple?
Iron.
Yes,
So is it ionic form?
yes. When apple is present in the when iron is present in the apple, it is present in ion. It is present in the ionic form, and ions are soluble in water. Ions are dissolved in water, whereas the iron that you are going to eat, it is the metallic form. The ones in the apple, in apple, when you are eating your apple, so you are getting iron as Fe3 plus. You are getting your iron as Fe2 plus. But when you're eating a pure metal, so you are getting Fe. This is the difference between them. Okay, anyway, come to our topic, which we were talking of, this brine solution. So in the brine solution, we have made the brine solution by adding sodium chloride. Again, sodium chloride. So whenever you hear about sodium chloride, just think of the common salt in your kitchen. Okay. So this is sodium chloride or common salt in water, which we have made a concentrated solution. So concentrated solution means it is 10 to 40% concentrated solution in water. Now, when we have mixed up sodium chloride in water, we know that sodium chloride in water will give us some ions. Just I wrote the reaction, and this is going to give me ions. Sodium chloride will break into ions as Na plus and Cl minus. H2O will also break to give you H plus and OH minus ion. So how many ions do you have in the solution?
Four.
Yes, there are 4 ions in the solution. Very good. Okay, so there are 4 ions in the solution, and we will now perform so for this one we use now 2 metal electrodes. So here we use we use 2 electrodes and connect these electrodes to a battery. So let's connect them with the battery. Now see what will happen in the solution. Once we have made the connections, I have made one of the terminal to be positive and the other terminal as the negative terminal. Okay. Also, just to add, I am also adding a switch in the circuit, so that whenever required, I can turn on the circuit or I can turn off the circuit. Okay. So to make this circuit work, I must put it on. So putting a dot in between, it symbolizes that the circuit is on. If I remove the dot, it means the circuit is off. So here, since the circuit is on, and now the electric current starts to flow. So one of the electrodes becomes positively charged, and one electrode becomes negatively charged. So here, our electrodes, this electrode becomes positively charged and this becomes negatively charged. Let's say this be our electrode A, and let's say this be the electrode B. Now see what reaction is going to happen inside the solution. So inside the solution, which are the positive ions?
Na plus and H plus.
Which ones are the positive ions?
Na plus and H plus.
Na plus and H plus. So these two solutions should be moving towards the negative terminal of the battery.
Yes, sir.
Yes. So in the solution, you have 4 types of ions. So let's say you have here inside the solution, you have Na plus, you have Cl minus, you have H plus, and suppose you also have now which one? Yeah, this one. You also have hydroxide ions. So out of these, which one of them will be moving towards the negative terminal of the battery? The one which are positive?
Yeah.
Yeah. So Na plus and H plus, they are the ones which are positively charged, and they are the ones which should move towards the negative terminal of the battery, as they will be attracted by the negative terminal of the battery. Okay, but at the negative terminal of the battery, the H plus ion, it accepts one electron from this negative terminal. Na plus does not accept the electron. Why it does not accept the electron? We'll discuss this in the later part of this. But out of these two, H plus accept one electron from this electrode. Why? Because the negative charges, they are traveling from this negative terminal of the battery. They are traveling from the negative terminal of the battery and coming to this electrode. So this electrode has a lot of electrons on it. When H plus comes near it, it accepts one electron from this, and so if H plus accept one electron from it, it becomes hydrogen atom. It becomes neutral. It becomes hydrogen atom. And two hydrogen atoms combine together to form hydrogen molecule, which is your hydrogen gas. So can I expect that near the electrode B, some bubbles will be formed, and those bubbles will be bubbles of hydrogen gas? Yes? Yes or no?
Yes, sir.
Yes.
Yes.
Yes,
So
sir.
at this electrode B, I am expecting here hydrogen gas to be collected. So at this plate, I expect hydrogen gas is collected over here. Now at the second electrode, let's see what will happen. So second electrode is positively charged. Okay. And out of this positively, since this is positively charged, so all the negative charges from this solution will be attracted towards this plate. So what all are the negative charges? In the solution, which ions are negatively charged?
Cl minus and OH minus.
Cl minus and OH minus. Okay. Now out of these two, it is the chloride ion which accept one electron from this terminal. Hydroxide ion does not accept. Again, we will talk of the reason why the hydroxide ion does not accept the electron from the battery. Okay. Sorry, does not donate the electron. They are not accepting the electron, they are donating the electron. Okay. So here, chloride it itself is negatively charged. So chloride ion, it will donate one electron at this terminal, at the positive terminal. So let's say what happens over here. At this point, chloride ion, it gives one electron and itself becomes chlorine atom. Cl, chlorine atom. The chlorine atom which is formed, it combines with another chlorine atom to give us chlorine gas. So at this terminal or near the electrode A, I will find bubbles of a gas which will be chlorine gas. Got it?
Yes, sir.
Okay, so up to now from the solution, what are the things that we have obtained from the solution?
Cl minus and and
Cl minus or chlorine gas?
no,
What we have?
and H2 gas.
Yeah, we have obtained chlorine gas. We have obtained hydrogen gas. And what all is left in the solution?
NaOH.
NaOH. So in the solution, you are left with Na plus and OH minus. So Na plus and OH minus, they combine to form sodium hydroxide. So does anyone remember the name that I talked of? What name was given to this process? In the very first class, when I started with this, I gave a name
Electrolysis,
to
sir.
this. No,
Chloralkali process.
chloralkali process. The name of the process was chloralkali process. So can anyone think why the name is given as chloralkali process? Why we are calling it as a chloralkali process? Can anyone think of why are we calling it? Bhavna, can you think why are we calling it as a chloralkali process?
Sir, first chlorine is that chlorine, no, sir.
Yeah, we are getting here chlorine. So that's why the name chlor. Very good. And
Alkali. Sir, alkali is basic.
NaOH is formed, sir. It's basic.
yeah, NaOH is formed, which is an alkali. So
It's
in this process, we are getting the products as a chlorine and alkali. That is why the name is given as chloralkali process.
Sir, could you
Now this,
explain this process once, sir?
yeah, sure. I'll be explaining this process once more, but in the next lecture. Okay. So currently, I'll just move on a little bit ahead also because to explain those topics, I need a flow. Okay. So flow means in the next lecture again it will be summed up. Once it will be summed up everything, or just before ending I will sum it up again.
Okay, sir.
Okay. So shall we move ahead?
yes, sir.
Okay. So what are the products that we obtained here?
Sir, NaOH and
What are the products, different products that we have obtained in this process?
Chlorine gas and gas, NaOH, and H2 gas.
Okay. So here in this process, we have obtained three products. The products obtained from this process, this is a very beneficial one since here you obtained hydrogen. In this, you also obtained chlorine gas. And in this, you also obtained an alkali, which is sodium hydroxide. And it is very difficult to manufacture sodium hydroxide as an alkali. Okay. Hydrogen gas is also very difficult to manufacture, but you are getting hydrogen gas over here. And all of you are thinking, or not you are thinking, the scientists are thinking of making hydrogen propelled vehicles. They are thinking of using hydrogen as a fuel. So we are also using hydrogen in the manufacture of ammonia, which will be further utilized for the manufacture of urea, which is a fertilizer. So hydrogen gas, which we have obtained here, it has a number of applications. Got it? The hydrogen gas which we are using here, it has a number of applications. So what are the different uses that we have seen? Hydrogen is used as a fuel. Hydrogen is used in manufacture of ammonia. It can be used to manufacture ammonia, which can be used for the manufacture of fertilizers. Hydrogen can also be used. Yes, any other? For the manufacture of HCl, hydrochloric acid. You have got hydrogen, you have got chlorine. So you can combine them to form HCl, hydrochloric acid, which is an important chemical. See, what are the different vast products that we are obtaining from this and different uses that we can have. Now from chlorine gas, as we know that chlorine is antiseptic in nature. So chlorine is used for killing of bacteria.
Disinfectants.
Yeah, used for or used as a disinfectant. It is also used for disinfecting disinfecting impure water. So it is used as disinfectant. There are other uses also for chlorine gas. Then alkali or sodium hydroxide, it has its own applications of manufacturing of other chemicals. Like it can be used for the manufacture of baking soda, washing soda. These are the different chemicals which can be used. It is also used in the manufacture of soap. So a number of wide applications are there for sodium hydroxide or caustic soda. So this process is really very important, as we are gaining here a number of products from this process. So important products we are getting. And what were the chemicals that we used for this? Can anyone tell me the chemicals that we used for the production of these?
Sir, NaCl plus H2O.
Yes, we just used salt and water. A simple common salt and water gave us so many important products. Okay. Now, one more thing, this was about the products. One more thing that we would like to clarify from this. We have also studied about oxidation and reduction reactions.
Sir, I'm
So
writing,
how,
sir.
yeah,
Sir, I'm writing, sir.
okay, just 1 minute. Just 1 minute, I'm opening up the page. Oxidation and reduction. Okay, so if anyone remembers the definition of oxidation, can anyone recall me the definition of oxidation again?
Sir, addition of oxygen and removal of hydrogen.
Okay, addition of oxygen, removal of hydrogen. Any other definition?
Sir, in oxidation, loss of electrons takes place.
Yes. So this is also there in oxidation. Just remember here in oxidation, we define oxidation to be in terms of loss of electrons, and we define reduction to be gain of electrons. So now out of these, see, if you observe these reactions, I have basically written here 3 reactions. Basically, 3 important reactions have been written over here. One of the reaction is here. I have written chlorine giving out 1 electron to form chlorine Cl. Here I have written a reaction H plus gaining 1 electron to become hydrogen. And here I have written 3. So out of the reactions 1 and 2 only, where is oxidation taking place? Where is oxidation taking place?
So, second.
See, reaction number 1 and reaction number 2. Okay. Where do we have oxidation taking place?
Both are gaining electrons, isn't it, sir? Like both are flowing.
See, at the reaction 1, chlorine is giving electron. At reaction 2, hydrogen is accepting electron. So by the definition, if you observe the definition again, loss of electron is called oxidation. So where do we have loss of electron? Where we are losing the electron?
First one.
First one. At reaction 1, there is oxidation taking place. Okay. So this is the plate where oxidation takes place. And always remember, the electrode where oxidation takes place, that electrode is named anode. Up to now, you are remembering the positive electrode is called anode, the negative electrode is cathode. No. Anode and cathode, they are defined in terms of oxidation and reduction. Wherever oxidation takes place, that electrode is called anode, and wherever reduction takes place, that electrode is called a cathode. So if I ask you, at anode, which gas is produced at the anode? Yes,
Gas.
which gas?
Chlorine gas.
Chlorine gas is produced at the anode, and which gas is produced at the cathode?
Hydrogen gas.
Hydrogen gas is produced at the cathode. Got it? Anyone having any doubt?
Sir, why only NaCl? Can we do this with some other products also maybe?
Okay. So now come to the last part, and then you will see why we used NaCl. We can use KCl also, but if you use KCl, you are going to get KOH. You will be getting here potassium hydroxide. Why we used NaCl? There are two reasons. First of all, it is easily available. The easy availability of NaCl. Is it easily available?
Yes, sir.
Yes. Is it costly? No.
No,
It's
sir.
not. It's
It is very cheap. It's very cheap. 1 rupee kilogram, 2 rupee kilogram. So this NaCl is very cheap. So that it is easily available. So that is the reason we are using NaCl here. Got it? You can use KCl also. If you use KCl, you will be getting KOH. But over there, now you need to find where you're going to find KCl. Got it?
Yes, sir.
Everyone is clear about this process? Okay. Now let me give you still again one more brief of this completely, so that you are aware of everything that has happened. Since whatever is written over here is just like a hodgepodge, made clear to you as a hodgepodge. However, everything is clear. First of all, let me remove this dihydrogen oxide. So can you drink dihydrogen oxide?
Yes, sir.
Yes, sir.
Even though it's dangerous.
Yeah, even though it's dangerous. And scientists are searching for it on Mars and everywhere. They are not able to find it.
Yes, sir.
So it's open. Chemistry is around us. Okay, it's not coming from somewhere. It's around us. So see
Sir,
here.
could you share that second page, sir?
Okay.
That
So this is given in a diagrammatical form in a textbook, right?
In your textbook, this diagram is not given, and explanation is given. Maybe some of they might have given this diagram also, but explanation is given. They have just given that in the chloralkali process, hydrogen gas is formed, chlorine gas is formed at the cathode. Also, chlorine gas is formed at the anode. At the cathode, hydrogen gas is formed. Okay, they have just given this statement. I will show you this in. You can open up your book, and some important chemicals from common salt. You have over there chloralkali process.
read it, sir.
Okay, so if you want, I'll show it to you just for 1 minute. Let me show it to you in your book only. So Yeah, here in my book it's given. You can search for your book if the diagram is given there or not. Common salt, a raw material for chemicals. Maybe in your book, maybe it's given in some other form. But it is there. Got it? This process is there in the syllabus. Okay. So we'll see again. We'll just quickly revise this in our next class also. Okay. Bye everyone. See you all.
Thank you.
Bye,
Thank you,
sir.
sir.
Thank
Bye,
you,
sir.
sir.
Bye, sir. Thank you.